Welcome to a lesson with Dr. Powell. Let's take a look at the lower bound theorem. We're going to be considering the negative x-intercepts and seeing how far down we should go and where we should kind of limit our searches. Now, if we looked at a list of factors of 8 divided by factors of 1, lowest we'd go down in that list would be -8, but that might be too low. Let's try -4 and try plugging in and see just what happens inside the synthetic division machine for the function. 1, -2, -4, and 8, and we proceed. 4, -6, positive 24, so 20, -80, and -72. Notice that these signs alternate, plus, minus, plus, minus. Now, if we ever notice an alternating pattern like this, then we know we've gone too low. So -4 is too low, and -8 is also too low, which means all the potential x-intercepts will be on this side, going this way. Now, let's think about that for a minute and think how that might be so. Well, for one thing, you'll notice that as we alternate signs, that coincides with multiplying this guy right here, this negative, to different things, and it kind of reverses signs a little bit. But also notice that these numbers are growing in absolute value. And so kind of the trend is to go away from 0 instead of going towards 0. So perhaps if this number is larger, that trend's only going to be amplified and you're not going to get to a 0 here. Kind of intuitively just a thought on why that might be so. But let's also take a look at a more rigorous way. If you're thinking about the divisor here as x plus 4, then we can take divisor times quotient. So x plus 4 times the quotient, x squared minus 6x plus 20, and then plus the remainder minus 72. So this is another view of the function. Just imagine what would happen if x is less than -4. If x is less than -4, then this part right here will be negative. You can try that out, or just think if x is like -5 or something, that's definitely negative. Okay. Now think about this part right here. All right, now as you plug a negative number in, notice that because these signs are alternating right here, we actually get that the output will always be positive, since right here we plug in the negative number less than 4 here, that's going to be positive because we're squaring it. Here, negative times a negative, that's going to be positive again, and the positive 20. Notice these signs right here, plus, plus, plus. In some sense, this is a lot like what happens with the reflection of Descartes' rule of signs. All the same sign after reflection, meaning there's no zeros. But for our purposes right now, we'll just kind of think about this as being just this is always going to be positive. This guy's always going to be negative, which means this whole thing right here will always be negative when x is less than -4. And if you have a negative and another negative, well, that's going to be, and you're just subtracting them like a negative, well, you're adding two negative numbers, this negative number plus that negative number, it's definitely not going to be 0. And so that works with anything that's less than -4. You don't really have to go through that process every time, but just kind of noting that if you see an alternating pattern right here, positive, negative, or negative, positive, it doesn't matter. It just has to be alternating. Then you know that you are too low and you should go higher and don't go any lower. Thanks for watching.